Modern code bases are complex because understanding them requires two different perspectives: what the code can do and what it actually does. I built Trace, an engineering intelligence platform that brings both together, using HydRADB as its underlying graph layer. Trace uses HydRADB to model the relationship inside an application, from repositories and files to function, API endpoints, dependencies, and eventually the runtime execution part. This graph is the foundation of the entire system. When I analyze a repository, Trace passes the code using its TypeScript AST pipeline and builds its static architecture into the graph. Instead of treating the code base as thousands of disconnected files, Trace turns it into a connected system that can be explored and queried. From here, developers can move through the architecture and understand how different parts of the application connect, from high-level components down to the individual functions and symbols. This also makes change impact easier to understand. If I change a function, I can investigate its relationship and see what other parts of the system may be affected, rather than manually searching through the repository. But there is an important limitation to static analysis. It tells us what can happen and not necessarily what actually happened. That's why Trace also has a runtime layer. When the application is instrumented with Trace, it records real execution paths and creates runtime entities such as request and execution span. Those runtime events are connected back to the static architecture through the same graph. Now we can move from a real request through its execution paths and back into the function and API responsible for that behavior. This gives developers both sides of the picture: the architecture that exists and the behavior that was actually observed. Finally, there is a AST trace which lets developer interact with this context directly. Instead of manually navigating through the repository, they can investigate relationship dependencies, functions, and execution behavior using the context trace as already built. The goal of Trace is simple: turn a complex code base into a connected, queryable representation of what it is, what it can do, and what it actually does. And hybrid is the graph foundation that makes those connections possible.